Yeah, good morning, sir.
Yes, good morning. Yes,
Sir,
good morning.
I want to present my. Sir,
Yes,
want to
yes,
present my.
yes, yes,
Want
yes,
to present my paper, sir.
yes, 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 yes.
Should I present,
Uh,
sir?
Let me start the session, then we will start the presentation also.
Okay, okay.
Yes, thank you. Good morning to one and all. On behalf of our MIT University in Tashkent, we feel elated and honored to welcome the gathering of scholars of various technical domains for the gracious presence on the third International Conference on Technological Advancements in Computational Sciences, organized by the MIT University Tashkent under the IEEE Kazakhstan subsection. It gives me immense pleasure to welcome session chairs for this session. Uh, Professor Dr. Ibrahim Atajanov, who is a professor at Tashkent University of Information Technologies, named after Muhammad Al Khwazirmi, Uzbekistan. And we have Dr. Rubina Khan, who is a senior lecturer at Imam Abdul Rahman bin Faisal University, Saudi Arabia. Uh, Thank you for accepting our invitation. Before start of the presentation, I would like to give some instructions regarding the presentation. The presentation time will be 8 minutes. Total 8 minutes will be available. Then after presentation is over, 2 minutes are available for the question and answer session. We have two session chairs, Dr. Ibrahim and Dr. Rubina. They will evaluate your performance, presentation performance, your contribution in the research on the 10 points. Out of 10 points, 4 points are reserved for the technical contribution, 2 points are reserved for the methodology, 2 points are reserved on the discussion on result and analysis, and 2 points are for the presentation. I would like to request all the participants to stick to their time presentation timings. We wish very good luck to all the presenters. Now we'll start the session. First of all, I think Dr. Deepak Kumar is ready, right? Dr. Deepak Kumar, your paper ID is 430?
No, sir. 525.
525. Okay. I would like to start with presentation with the paper ID 525, and the title of the paper is Cataract Disease Identification Using Transformer and Convolution Neural Network, a Novel Framework.
Yeah, right, sir.
Dr. Deepak Kumar is available. Dr. Deepak Kumar, you have 8 minutes. You may share your screen and start your presentation. Thank you.
Okay, sir.
Please start. Please start. It's visible.
1 minute, sir.
Yes, yes.
Am I audible, sir?
Yes, yes. Please start, sir.
Okay. Good morning to all. My present paper topic is cataract disease identification using transformer and convolution neural network. It is a novel framework I have designed, and thank you for giving me this opportunity, sir. So first of all, I want to give the abstract of my paper. Actually, my paper is on the particularly devoted to the cataract classifications, and as you know, disease detection is a disease detection in the deep learning is a challenging task in the today's scenario, and due to the diversity of health diseases and regional characteristics associated with them. And cataract is a common eye condition that can lead to the visual impairment and blindness if not detected and managed effectively. Actually, I have taken two CNN model and one transformer model. Two CNN model include VG16 and ResNet 50, and another model is called Vision Transformer, which is prevalent in the today's scenario. And I have implemented the cataract detection using these algorithms my paper consists unique thing is I have used median filtering to technique to reduce the noise and enhance the image quality before going to the data before going to the classification. Okay, so I have used data augmentation technique which are specially used for overfitting and expanding the data set. And my uh, unique thing is that my VIT model outperform all three models among the three models and got 70% accuracy, which is a very high accuracy as compared to the existing work. So before going to this journey, I want to introduce my topic. As we know, the human eye is a crucial sensory organ, and but many people in the rural and urban area suffer from the eye disorder like cataract, glaucoma, and visual impairment. And these are the problems due to the age, genetic, and modern lifestyle. And I have taken the cataract problem, which is especially you occur in mostly persons due to the age problem. Okay, and I have used two types of images. One is cataract type, another is called normal images, and implemented using medical image classification using a deep learning techniques. And new technology, as we know that transformer is very famous in these days. And researchers have examined the deep learning medical in the medical domain, particularly addressing the cataract disease to affecting the eye disease. I have collected the data set of 612 images, and the proposed model is aims to classify the eye images and normal images and infected with cataract disease. The paper primary contribution is to noise reduction technique and explore the working of CNN models like VGG16 and ResNet 50, and also use the VIT model to extract the relevant feature from the eye images. So several studies have been done in these studies, and on the mostly data set like glaucoma, cataract, these are the data set which have used in the existing studies. And in these studies, mostly models are used VGG16 and ResNet 50, and they have used image segmentation technique to achieve the result. And Nazir sir has also used DenseNet 100, and they have improved the CenterNet data set to adopt the 2019 data set, okay, and have achieved the accuracy. So S. Verma and K. Prashil curated the custom data set. They have customized the data set and collected the mostly images from the Google and GitHub data sites. And they have applied the transfer learning with VG16 and ResNet 50, and also used the Inception V3 and found that outperforming results. So as we know, transformer is a new category of deep learning model. They use the attention mechanism to enable the selective focus on the specific input of the region, so enhancing the efficiency. And initially, researcher you explored the application in image analysis, but adapting the transformer for image task based was a challenge due to the extension due to the attention model. Actually, transformer is famous for that due to the attention model, and I have used that. This is the research diagram I have used. First of all, I have taken the image dataset of 612 images and performed the data augmentation to prevent the overfitting. And after that, I have used the uh, uh, media filtering to remove the noise. And I have implemented this using transfer learning called VG16 and ResNet 50 for importing the features, and also use the transformer model called vision transfer model. In the vision transfer model, as we know, there is a requirement of patches. So I have implemented the first of all images patches and give it to the visual transformer, and the visual transformer multi head attention model is going to implement the attention on a selective parts and going to classify the cataract or normal disease. Okay, I have used the VGG16 and ResNet 50 model also, but these model are used with the transformer model and transfer learning techniques. And from the transfer learning technique, I am using the CNN features, and after that, I am going to flatten the data set, flatten the features, and going to use the softmax layer for my data set for binary classifications. So the proposed architecture I have used here. So this is the results, and as you know, as the results visualized, VIT achieved the accuracy 70%, and on the cataract the precision accuracy is 79% and the normal accuracy is 65 as compared to others. Okay, from the confusion matrix I can see, I can show that the 34 and 51 are the images which are accurately predicted. Okay, 34 are from the cataract and normal extracting the 51 images for right images as compared to that. And ROC curve is showing the my model cataract, my vision transfer model is achieving best result under the area under curve 78%. So these are the results and discussion section. And so conclusion of my research is the research is aimed to develop the deep learning model for cataract eye problem using 3 deep learning models. And I have used a data set called cataract data set, which consisting the 612 images. And the 3 model I have used Resonate 50, VG16 and Transformer model, which is very famously called Vision Transformer model. And Vision Transformer model achieves 70% accuracy and balanced recall and F1 score on the as 70% to differentiate between cataract and normal classes. And VIT outperformed other than deep learning model, providing the most effective classification accuracy of the binary classification task. So in the future, I am going to expand the data set by collecting the more and more cataract or other disease images and going to perform the using the transformer model by including the CNN model and VIT model to ensemble using the ensemble technique. I'm planning this data set. So thank you for my side. Any queries, sir?
Thank you, Dr. Deepak Kumar.
Yes, sir.
On your presentation of the use of the transformer and convolutional neural network.
Yes.
I would like to request Dr. Ibrahim and Dr. Rubina for the questions if they have.
Yeah, I'm Ibrahim, and I have a question.
Yes.
So, as you said, like as I see that you're kind of tested 3 deep learning techniques and evaluated between those. I wanted to know if there are any existing solutions that you can kind of comparatively evaluate, because I see like a 70% accuracy.
Yeah, very little accuracy. Actually, I'm planning to expand this accuracy in the coming future. And
okay.
Yes, sir.
Okay, yeah. So you have a plan to evaluate your proposed solution with the existing ones, right?
Yeah.
In the future. Yeah. Okay. Yeah. I have no other question.
Good morning, everybody. Good morning, Mr. Deepak.
Yes.
Thank you for sharing your research with us. It's a great pleasure to know something more about the details about the new research and technologies. I just have one question to you, that apart from these 3 evaluation models that you have used, the extraction techniques, you were saying that you are planning to propose a new, you have to expand your data set and you will be applying some other model on this data set, right? So why you did not apply the same the same model here?
Actually, after exploring these models, I have come to know that at this time, the other things can be possible if I am going to implement the ensemble technique. But on the learning time, I have implemented these, so the time limitation can be the constraint for me.
Okay. Okay. So in the next paper, when you will be applying some other model,
actually,
can the models be compared?
Your sister university is UP, and I am planning to expand this in the coming paper, which I have implemented. and also going to present the paper in the December.
Okay. Thank you, Mr. Deepak.
Yeah, thank you, ma'am.
Okay, thank you, Dr. Deepak Kumar and Dr. Ibrahim and Dr. Rubina. Now I would like to call the next paper ID is 351, data mining techniques for ensuring security in large data sets. Paper ID 351. If the author of the paper ID 351 is present now, please start your presentation. You may share your screen and you have 8 minutes. Please start. Paper ID 351. Any author of the paper ID 351 available now? We'll move to the next paper ID 430. 430. The title is Detection of Counterfeit Currency Notes through Machine Learning Algorithms and Image Processing. Paper ID 430. 430.
Yeah, good morning, sir. I'm Dr. Sandeep Kumar. I, along with my other colleagues, Dr. Vikrant and Dr. Amit Sharma, will be presenting this paper. Now, this paper is basically on currently prevailing issues, particularly in country like India, where currency detection, that is fake currency detection, is a very big problem. And regarding that, we have tried to find certain solution. So we have applied various models and tried to improve something.
Sorry to interrupt, Dr. Sandeep Kumar, please share your screen.
Dr. Vikrant Shokeen will be continuing with the presentation.
Okay, please share. You have 8 minutes for the presentation. Please share screen and start.
Is the slide visible, sir?
Not yet. Please share it. Try one more time. It's not visible. Yes, yes, it's visible now. Please convert into presentation mode and please start. You have 8 minutes. Dr. Sandeep Kumar, you may start now. You're not audible. Dr. Vikrant and Dr. Sandeep Kumar, your presentation started, but you both are not audible to us. Your screen is visible, but you're not audible. Please check your mic.
Sir, am I audible?
Now you are. Dr.
Okay,
Sandeep
sir.
Kumar, you are audible now. Yes, please start.
Sir, I'm Vikrant Shokin. Actually,
Okay. Okay. Dr. Vikrant, you have 8 minutes. Please start now.
I'm
May I request Dr. Sandeep Kumar and Dr. Vikrant to try after some time. Meanwhile, we'll continue with others. Is it okay? Dr. Sandeep Kumar, may I request you to start after some time. Meanwhile, we'll continue with the other paper ID. Is it okay? Yes, yes. Okay. We'll move on to the next paper. The next paper ID is 460. Detection of deep fake images using convolutional neural network. Paper ID 460. Paper ID 460. If one of the author of this paper is available, please start your presentation now. Paper ID 460. We'll move on to the next now. Paper ID 242. 242. The title is An Adaptive Deep Dr. Sandeep Kumar, are you trying to present now? You are not audible. Hello. Dr. Sandeep Kumar or Mr. Vikrant Shokin?
Sir, am I audible?
Okay, your paper ID is 430.
Yeah, sir, am I audible now?
Okay, okay.
Sorry for the inconvenience, sir.
Please continue now. Please continue.
Right, sir.
You have 8 minutes now. Please
Right, sir.
start the presentation mode and start your presentation. Please start.
So I am here to present my paper. Sorry for the inconvenience. The detection of counterfeit currency notes through machine learning algorithms and image processing. As we all know that even after demonetization in 2016, which main objective of that was to eradicate counterfeit notes, but it still pose a challenge for us. The effects of counterfeit currencies are like reduction in the value of real money, inflation, terrorism, and all. As we know, in the modern financial sector, identifying fake currency is a constant struggle. In order to address this issue, this research introduces a technique that correctly and quickly detects fake certifications by fusing the machine learning and image processing. The suggested method trains a machine learning model with information from photos of actual and fake banknotes so that it can categorize and recognize the distinctive characteristics which are available on the currency and patterns that separate real and the fake currency. Now, different image processing techniques are employed to enhance image quality, lessen noise, and boost the clarity of crucial features. The first step is to feature extract, and the efficiency of that depends on the how effectively the features are extracted. And the next is in identifying fake currency were tested using the results. The proliferation of counterfeit certifications can be stopped or it can be lessened down, safeguarding the economy and boosting public confidence in the system, which is the most important thing, and with the help of machine learning algorithms and the images. Now, these pose a major threat to global financial systems and economies. Conventional methods of spotting counterfeits often depend on human expertise. As we come to check the currency in our hands, and we can predict that by our human expertise and take up considerable amount of time, and we are not sure about that all the time. And the advancements that's why the advancements in image processing techniques coupled with machine learning algorithms have revolutionized the process of catching the fake currency. The technology enables us to extract useful details from photos of money like texture, color, shape, and geographical data. These traits can be integrated into machine learning models to enhance their accuracy. The method seeks to increase detection accuracy, decrease verification time, As part of the research technique, a broad data set of real and fake cash notes is gathered, which is divided into 80-20 and covering different denominations and currencies. The quality of currency images is improved using pre-processing methods, that is canny edge detection, which we have used. The data set is subsequently used to train machine learning models that categorize the money notes as fake and real. There are existing systems. Different vendors have machines in the market for detection, which use these techniques and manually checking the images for particularly for Indian currency we have used. This is the literature survey. Various researches have already been done. Then various machine learning algorithms are used to identify the authenticity of currency notes and compare and contrast which of these algorithms is best suited. The Mrityunjay Singh and all, which is a compact, mobile, and devoid of any hardware components to help ascertain its legitimacy. And they applied an edge detector algorithm to counterfeit banknote photos in order to extract the most important data. Next, Megha Yadav and all research focuses on the examination of banknotes from different currencies by extracting their intricate features meticulously in order to attain high precision and optimal performance in terms of loss and accuracy during the training and validation time, particularly when working with huge data sets. Now, there is also a research called Deep Money Innovated Tool by Tokir, an amalgamation of GAN, that is generative adversarial networks, and image processing methods. This machine learning approach can precisely spot genuine paper currency with 80% competency rate. Image processing through machine learning techniques has proven to be a reliable way of identifying counterfeit currency, as shown by the development of deep money. This is the proposed architecture that in the first phase, the currency is inputted and the segmented, the features, the most important features of that particular currency is extracted, and that is fed to the similarity measurement. And the similarity measurement also has the database that is trained, and the features extracted from that trained database, then it matches them both. And if it is the valid node, then it is authenticated, otherwise unauthenticated. Different parameters, performance parameters were used: accuracy, precision, recall, F1 score from the confusion matrix. And these were the results: accuracy comparison of the SVM, random forest, and CNN, and then classification analysis depending on the precision, recall, and F1 score. But CNN was the accurate model, most accurate model of all the three. These are the some snapshots from the edge detection, that is image processing. First, figure 2 is the features are not matched, and the figure 3 is features matched, although the for the 2000 rupee note, Indian rupees. Now there is a future scope also. Through the fusion of advanced machine learning methods like CNN and SVM with image processing, such as edge detection and texture analysis, the proposed method exhibits commendable performance. It also sheds a light on the imperative there is a need to continually enhance and adapt standards and keep working on that for the against counterfeiting, to keep pace with the evolving landscape of AI. These are the references. Thank you. Thank you.
Thank you, Dr. Vikrant Shokin. I request Dr. Ibrahim and Dr. Rubina for the questions.
Okay, let me go first again. Thanks for the presentation. It was a nice work. My only question is that, is it feasible kind of using just visual information for distinguishing between fake and real currencies?
Right.
And okay.
Right. The features get extracted in the first part, that is image processing. In that case, the features are extracted, like features of that edge detection, their numbering is there, some marks are there, some watermarks are there. These features get extracted, and they are, after that, they are fed to the segmentation, classification, and then the generator.
Actually,
Okay.
sir, this can be, excuse me, sir, this can be like a primary checkup, and that is first phase of verification. Later on, like further physical verification and other techniques can also be integrated to get better results and better, like exactly like accuracy of the work.
I see. Yeah, I see. And it would be nice if you put more details about the technique that you are using, the methods, into the presentation.
Right.
Yeah.
Right.
Okay. Thank you.
Thank you, sir. Thank you very much.
Thank you, Mr. Vikrant, and thank you, Mr. Sandeep, for presenting your work. It's a good study that you have done. Just one question for you, apart from the features that you have proposed, any other feature that you would like to incorporate?
Yeah, ma'am, we are working like we are trying to incorporate some additional features like hybrid mode of like detecting the quality of the paper and that type of parameters also we are trying to include so that the accuracy can be further improved in practical sense of usage.
And can the same model be applied to check the currency for any other countries, or it will be only applicable for India?
Yes, ma'am, it can be applied, but depending on the data set,
You are not audible, Mr. Vikrant.
ma'am, it can be applied, but it should be trained on that particular currency.
Okay. Thank you, Mr. Vikrant. Thank you, Mr.
Okay.
Sandeep.
Thank you, ma'am. Thank you, sir. Thank you very much.
Thank you, sir.
Thank you, Dr. Vikrant, Dr. Ibrahim, and Dr. Rubina. Dr. Vikrant, you can unshare your screen now. Now I would like to call paper ID 351. Any author of the 351 is present? 351. Author paper ID 460, 460. Author ID 460. Author ID, paper ID 242. Paper ID 242, 242.
Hello.
Yes.
Yes, paper ID 242. My name is Aman Shakya.
Okay. Paper ID 242 and the title is an adaptive deep learning technique for breast cancer diagnosis based on dataset.
Yes.
Please start your presentation. You have 8 minutes.
Thank you so much.
Please continue.
Please let me know if my screen is visible to all of
Yes,
you
yes, it's
guys.
visible. Please. Yes, it's
Thank you so much.
visible and you're audible also.
Thank you so much. So, first of all, good morning, everyone, and thank you so much for giving me the opportunity to present my paper among you all. My research title is an adaptive deep learning technique for breast cancer diagnosis based on the data set we had. So this is basically related to breast cancer detection, which is mostly common in women's. I can say like I can say breast cancer is super common among women, and catching it early, it's making a huge differences in the outcomes coming in nowadays. So what we have done, I can show you in the abstract section. Like the ultrasound imaging that we have used is a very safe peak, I can say, to troubleshoot the issue. Like in the early stages, what models used to solve this issue were not giving the accurate results, but now if as we have CNN and we have other advanced models that can analyze the images by using deep learning, we can get the results better. Like I have mentioned in the third point, like ultrasound image of breast tissue can provide detailed information. So we are extracting more and more features from the images analyze uh, to analyze the report, which can give more accurate data. So here we are using convolutional neural network which is basically a type of deep learning algorithm that helps us in recognizing the features from the image and classifying it into the tasks. And we are using Python Spider IDE 3.7 for simulations. So hello.
Yes, yes, please continue.
Yeah, sorry. So basically, breast cancer is increasingly common among both older and younger women. So, and the mortality rate remains high despite advances in treatment. Early detection is critical for effective treatment. So early screening and precautions are needed. So deep learning techniques like CNNs have potential for early and accurate predictions of diseases through data analysis. So what our solution is doing here is using the base paper which is published in IEEE 2022, which had accuracy of 84.9%, which we have enhanced to uh, some 99.31% in our current model, and also reduce the error in the paper. This is my literature survey, and this is the proposed architecture. So basically by after reviewing the literature uh, surveys, I identified the problems like it had the low accuracy rate on true data predictions, like for the data sets we had available in the past. Traditional system analysis were not sufficient to provide the proper feature extractions. Also, there were classification errors in the previous models they used to implement in the SVM model. So what we are proposing here is like to collect breast cancer disease data set from Kaggle machine learning reciprocities, and we are implementing deep learning classification algorithm for the cancer disease predictions. We are simulating it in the same way. We are calculating various parameters like precision, recall, F1 accuracy, sensitive error rate, and specificity of the data. And we are also comparing here the simulation result with the previous works we have present. This is the proposed architecture we have designed, and these are the basic methodologies we are using in our research. So image acquisition we are using from the Kaggle machine learning repositories. We are pre-processing the data, uh, like at the time of pre-processing we are removing the unwanted data from the data set. Here we are handling the image resize, rescaling of the image. Feature extractions we are doing by GLCM, that is gray level co-occurrence matrix. That is the statistical technique we are using for feature extraction, and classification. Also we are using convolution neural network. So how we are predicting it in the prediction process, basically we are uh, analyzing the complete image. You can see the data set we have. So we are first of all we are breaking this particular image into pixels. Then we are pre-processing image by its color, size, and scale. Then we are splitting it into the training and testing sets. Like here we have used 780 images. Among them 600 let me remember what data we are using. 600. Okay, I can show you. Where did- Yeah, sorry. 624 images we are using to train our model, and 156 images we are using for the test. So these are the images we are classifying by the pixels. Like, we are breaking the image into the pixel, and then we are just comparing the colors of the pixel. Like, RGB is the by default, which is giving us no error, but once we are finding any grayscale shade like white, black, or any other texture from that particular combination, so we are alerting it as a issue. Okay, so these are the results of the data sets we have. Okay, so this is the first simulation result we have found, in which we didn't see much number of classification errors. I mean, they were better than the previous existing solution available. These are the comparisons we have mentioned in the last point. Like, we are also comparing it from the previous work that was based on the quadratic SVM model. So yeah, it had the accuracy of 84.9%, and we are achieving it till 99.31%. So till this point, we have technically we have achieved the success rate of 99.31%, which we can okay, I'll explain that in the future enhancement section. So before that, I am just concluding it. So what we have done is, in this particular research, is by using the ultrasound images, we are predicting the breast cancer diseases more better using the deep learning techniques like convolution neural network. In this research, we have trained and tested this data set successfully. Accuracy is better than before, and the errors are also reduced by a very good percent. So what, like, till now we have reached to 99% of the accuracy. So what other things we can do in future with this particular researches, this can be applicable for analyzing other diseases as well. Like, this research was based on only for breast cancer diseases, but some other cancer related diseases are also the also a big issue in the world. So we can also classify other techniques for those kind of cancer diseases. Yeah, I mean, these are the references we have used to build our research. Thank you.
Thank you, Mr. Aman, for the presentation on adaptive deep learning techniques. Now, I would like to request Dr. Ibrahim and Dr. Rubina for the questions.
Thank you,
Okay,
Mr. Aman. Thank you. Go ahead,
yeah,
Mr. Ibrahim.
Dr. Abhinay, you can go ahead this time.
Okay, thank you, Doctor. Thank you, Mr. Aman, for presenting your work. I expect that you would have explained the existing models really better than we just saw the names and the analysis, that's it, but it could have been explained in a better way. This model analyzing only breast cancer, or it
Yes.
can be applied to any kind of breast cancer, because the cancerous tissues are same, whether it's a breast cancer or any other cancer.
Yeah, yes. So yeah, so the threshold of images we are using at the time of breast cancer related ultra. Sorry, am I audible?
Yes, you are.
Yes, please continue.
Uh, okay. I thought there was some glitch. Okay, so we are using threshold of the images that contains all kind of images related to breast cancer. So by like how we see the breast cancer, some kind of sloth we have in tissues, right? So wherever the sloth is coming in tissues, so we are detecting that, and we are analyzing over the pixels in terms of image here, by for to analyze the results. So for now, we have tested and trained the model on breast breast cancer related data only. But yeah, as I have mentioned in the announcements here, we will look into other diseases also.
Okay. Because it's just an ultrasound image that you are capturing. So ultrasound image can be of any cancer.
Hello.
Thank, thank you, Mr. Aman. Thank you. No more questions.
Okay.
Can
Okay. Yeah.
we
Thank
so
you, Mr. Aman, for a nice paper. And the accuracy was very outstanding. Oh, okay. Go ahead.
till the date.
Hello. Hello. Am I audible?
Mr. Aman, you are not audible now. Mr. Aman?
Can I continue with the question?
Yes, yes, please. You continue. He will answer later. No problem.
Okay. So I think the accuracy is. I think we're having some issues.
I just tested on breast cancer related.
Oh, okay.
Dr. Ibrahim, you may ask him the question. He will answer accordingly.
Yeah. Okay. So the accuracy and the precision and recall are more than 99%. It could mean that the problem is total is solved, or there is a overfeeding issue in this.
Yeah,
work.
almost.
So that's why I have
Yes.
a concern about this because you either solve this problem totally using the ultrasound. As you know, the ultrasound is very efficient only for dense breast type of breast. Otherwise, the mammography and different kind of radiology imaging could be the better solution. So I have concerns about this results that you have, and also, did you use the CNN like a deep learning for feature extraction, or you didn't use you use other techniques for feature extraction? If you use other techniques, then it's not a deep learning. Yeah. Those were my concerns.
No, I have used CNN only for now. Yeah, because in the previous versions, they were using SVM models to analyze the solution. And that's why they were not reaching to the particular end result where the accuracy can be better. So what I have mentioned in the starting when I was introducing the product, this can be solved earlier as well. But the difference there was choosing the approach only. So we have found the CNN technique here to get better results than previous.
Okay. In your overview, on the diagram that you showed that you use CNN for the classification part. That's why I was a little bit confused. If you use the CNN for feature extraction part as well.
Can you give me a second?
Yeah. Okay. Go back.
Yeah. Here.
Go back. Yeah.
Okay.
Where you showed the diagram. Yeah, this one. Yeah. So you used the CNN only for the classification after feature extraction, or used the, I don't know, like deep learning technique for the totally for this work, like end-to-end.
Yeah, I mean,
learning.
yes, we have used CNN only for that.
Yeah. What kind of technique did you use for feature extraction? I think you already mentioned that, but I wasn't, I couldn't catch that if it's kind of trained together, like end-to-end training. If it's not trained together, then we cannot say deep learning.
Yes, you're right.
Okay, those were my questions.
Yeah, I mean, yeah, I'm in from the presentation perspective, it's not showing correct in this particular flow chart, but yes, we have used the
Okay.
convolutional neural network for feature extraction as well. Like I have mentioned the solution. Yeah, the algorithm is not mentioned in this particular presentation, but when I was explaining the solution, it was like we are extracting image features from the raw pixel data, and when we use CNNs for image feature extraction, they basically extract our data hierarchically from raw pixel data, and then making them suitable for image classifications and object detections, right? So this is where we have used CNN in this particular solution. Like yes, I had to connect the link from there. So sorry for that. I'll correct it, but I have
Okay.
mentioned it in
Okay.
the paper. Yes. Yeah. Yeah.
Okay. Thank you.
Yes.
Thank you, Mr. Aman,
Yeah, thank you so
Dr.
much.
Ibrahim, and Dr. Veena. Now I would like to, Mr. Aman, you can unshare your screen now so that
Sure.
the next presenter will start. I would like to call the paper ID 243. 243. The title is An Efficient Machine and Deep Learning Classification Technique for the Depression Using EEG. Paper ID 243.
Yes, hello everyone. I'm
Yes,
sharing my screen.
Miss Yasmin. Okay, please share.
Yes.
Miss Yasmin, you have 8 minutes for the presentation. Please start now. Share
Okay.
your screen.
Yes, is my screen visible?
Yes, yes, please start. Paper ID
Okay.
243.
So, good morning everyone. My name is Yasmin, and my research topic is machine and deep learning technique for detection of depression using EEG data. So, the abstract is, as we all know, that how depression is affecting people, how people are getting depressed a lot, and depression is very common, but it is a very serious and mental health issue which affect how a person feels, thinks, and acts. It can make daily life really hard, and normal. Basically, my research is based on detecting depression using deep learning and machine learning. So, and I've used EEG signals. So, EEG is a electroencephalogram, which is like I can say, which is a process, and in which represents that how signals are going into a person's brain. And it is also like the map of electrical activities going in a person's brain, and it is also of brain activities that occur in a human brain. So during this process, a cap has been placed over the head to detect, and it is also like sorry, to detect, like it is a way to communicate with the human's brain. Yeah. So, using EEG data, we can identify various types of brain-related diseases like sleep disorder, brain injuries, brain tumors, mental disorder, madness, and depression. So, my thesis is all about how engineering concepts and techniques can help in biomedical industry. And yeah, give me a minute. Yeah. So, introduction. The EEG signal that plays an important role in the healthcare system, especially in mental healthcare area, and also in depression and madness. So, like depression disorder is one of the leading causes of burden of diseases today, and it is assumed that it will take first place in the world in 2030. So the early detection of depression requires a patient friendly inexpensive method, basically. And but now, as technology is evolving, so we need to use some technical tools. So here like we are using EEG process. So this is the waveforms that are EEG signals. So this red one, yeah, so this is showing the total energy of EEG signal, and gamma band. The second wave is a gamma wave energy. So a gamma wave energy is basically referred to the brain activities with the high frequency that ranges from 30 to 100 hertz, and then the beta band energy. It is it is a frequency which occur from 8 to 12 hertz, and it it associate with light sleep. The next is alpha band energy, and it ranges from 4 to 8 hertz. And like when we close our eyes and get relaxed, then these waves become more prominent. Then next is theta band energy. Theta band energy occur in the frequency range from 4 to 8 hertz, and it associate with light sleep. And the final waveform is of delta band energy. It operates in very slow range from 0.5 to 4 hertz, and it dominates during deep sleep and rest. So during the research of this thesis, I have I've studied so many papers. So some of these are here. The first one is from ACL, and it got published in 2021 in IEEE conference. So his work was a deep convolutional neural network framework for detecting vibration using EEG, and he was able to achieve 91% of accuracy using CNN method. The second paper was from S, and it got published in 2020 in IEEE, and his work was EEG that was based on deep recognition by combining functional brain network and traditional biomarkers. So he was able to provide a classified distinguish depressions from a normal control. And then these are uh, some more papers I have studied. So, like in this part, it is visible that the data set I've been used, data set I have been used, that is from Kaggle website. That is a standard data set provider. So the data set, initially the data set work as a input data, and after that the pre-processing of data has been done. In the pre-processing stage, it involves cleaning of data and preparing data for analysis. It remove null values, and it handle the missing data. After that, the next stage is features and splitting. So in this stage, the data got split in two set, is a training set, and the second one is testing set. So normally 7 to 80% of data is training data, and 20 to 30% of data is machine learning works on self experience. So before the data should be done, so that the testing of the data can be done easily. Next step is classification. Classification includes two methods. First is KNN and second is LSTM. KNN is K nearest neighbor. It is a machine learning method, and LSTM is long short term memory, is a deep learning method. So these two methods I have used here. Yeah. And the final stage, performance analysis. Performance analysis includes some four metrics. The first one is accuracy, precision, and then the event measure. So this is a description of flowchart. The data set that I from Kaggle website. It will uh, it will act as in initial data, input data, and then the group data for handling missing data and for removing null values. And then the extracted data will split in two parts: training data and then testing data. And then the machine learning method and deep learning method is applied on the data, and then a confusion matrix is generated that will be based on prediction classes like true positive, false positive, true negative, and false negative. And finally, the performance parameters will be calculated. Yeah. So this is the this image is showing the data sets, how we will be able to see it when it come in the machine environment. So these are the columns, and these are the rows, and these are the data sets. And as I have told you that the data got split in two parts: the training data and testing data. So this is training data, and then this is testing data. And next is classification report. So this report is based on KNN method, and these are the values and factors on the basis of which we are able to find the data. With KNN, we are able to find 94% of accuracy, and these are the average values. Then this is LSTM. With this method, we are able to get 96% of accuracy in our data. And then this is simulation result for KNN. So as we are able to achieve 94% of accuracy, and classification error is 5.86%, and then precision value is 97%, and then recall is 94%, and then F measure is 95%. And then this is simulation result for LSTM. With LSTM, we are able to achieve 96% of accuracy, and classification error is also 3.52%. This is the comparison between a previous work and proposed work. So in the previous work, I was able to achieve 91% of accuracy, and now after like working on it in the proposed work, we are able to achieve 96.8% of accuracy. And then before that, the classification error was 9%, and now it reduced to 3.52%. Precision was also 91, and but now it is 99%. The recall was 88%, and now it is 94%. And like F measure was also 89% before, and now it is 97%. In previous work, I have used CNN method, and in the proposed work, I have used KNN and LST. And so the conclusion, the propose the purpose of this research is to identify and to detect the depression using EEG data, and with the help of machine learning and deep learning techniques. So here I have used the Spider IC 1447 version software, which is based on programming language Python. And I have used two methods, that is KNN and LSTM. With KNN, I'm able to achieve 94% of accuracy, and with LSTM, 96% of accuracy. And existing work is better than the previous work. And for the future enhancement, we are thinking to consider other different data sets to check results, to work with different data sets and get results at how it's working with other data sets, and to apply hybrid machine and deep learning techniques, as a hybrid machine is more complex to work with. So this I will work on this, and then just get to know about it more. And I'll include various other parameters that can be calculated and enhance the performance. And in this research, I took EEG signals. So I'm planning to consider ECG signals and EMG signals both to predict some more diseases. Yes. And then these are the references. Thank you.
Thank you, Ms. Yasmin, on the presentation of use of machine learning and deep learning classification techniques. I would like to request Dr. Ibrahim and Dr. Rubina for the questions.
Okay. I have a question about the the evaluation part. The thing is like you evaluated your current method with your own previous method.
Yes.
Why you didn't evaluate your method with other state-of-the-art methods?
With other?
Yeah, from different authors.
Author? Actually, I'm not able to get your question. I'm really sorry.
Okay. Is the previous method that you compared, is it your method, like the authors are, is it what I'm saying, like that if you compare with your own method, like a previous method, then yeah, I think you should also compare with many other state-of-the-art methods as well. And you, in your presentation, you also mentioned some other solutions with their outcome, but the outcome format was different. Like some has the accuracy number shown, the others was just I don't know, like a text like it outperformed something like this. So there wasn't clear comparison that I get.
Yes, here the previous one and the proposed work. Yes, the previous work was from my base paper and the proposed work is from this one.
Yeah, it would be nice if you compare with other state-of-the-art methods also, not just one method, which was your own.
Okay.
Yeah. Okay.
Okay. Yes.
Yeah, I'm done.
Thank you, Ms. Yasmin. It's you explained your work in good details. I have no questions for you. Thank you so much.
Okay, thank you so much.
Thank you, Ms. Yasmin, Dr. Ibrahim, and
Thank you so much all.
Dr. Rubina. Ms. Yasmin, you may. I would like to call the next paper ID number 42, an experimental analysis to measure the impact of data size on accuracy of deep learning model to detect and classify monkeypox using skin lesion images. Paper ID 42. Paper ID 42. Opinion of the author of paper ID 42 is available. Please start your presentation. Paper ID 42, no? We'll move to the next. Paper ID 355. Paper ID 355. Analysis of land surface temperature fluctuations using remote sensing data. Paper ID 355. Any author of the paper ID 355 is present. Next one is paper ID 326. 326, and the title is Quantum Odyssey, Traversing the NISQ Era's Quantum Terrain. Paper
Yes,
ID
sir. Paper I 326 available.
326.
Yes, sir. 326 is available.
Yes, please start your share your PPT, and you have 8 minutes for the presentation.
Okay, sure, sir.
Please start. Yes.
Okay. Good afternoon, everyone. This is Swati Ara, and I'm presenting on Quantum Odyssey, Traversing the NISQ Era's Quantum Terrain. So this is the index which we'll be discussing further in our presentation. So the advent of quantum computing has ignited unprecedented anticipation. This has transcended the limitations of classical computation and revolutionized various facets of technological advancement. At the forefront of this quantum revolution stands the noisy intermediate scale quantum NISQ era, characterized by a delicate interplay of immense potential and persistent imperfections. Although quantum computing's theoretical underpinning have long captured the attention of academics and technologies, putting it into practice has proven to be a challenging endeavor. The noisy intermediate scale quantum era emerges as a pivotal juncture in the journey towards harnessing quantum power for real-world applications. So before diving further, it is essential to have an understanding of its background. Like NISQ is based on the innovative ideas of Feynman and Dodds, two of the first people work on quantum computing. It recognizes the difficulty of noise and mistake in quantum system. Because of this, John Perskill came up with the term in 2018 to describe a time when quantum computers work at a level above classical computers but below fault-tolerant quantum machines. In the past, advances like Shor's and Brewer's algorithm showed what quantum computing could do. Even though quantum decoherence exists, NISQ devices and error correction methods have been made using platforms like superconducting qubits and trapped ions. So the various key aspects distinguishes quantum computation from classical computation. Like superposition in classical computing, a bit is either 0 or 1. In quantum computing, a qubit can exist in a superposition of 0 and 1, collapsing to one of these values upon measurement with specific possibilities. Entanglement, qubits can be entangled, meaning the measurement of one qubit instantly determines the value of other without the need for measurement. Inference, quantum operations can manipulate the probability amplitude of quantum qubits measurement result, potentially increasing or decreasing or even excluding certain outcomes. Like quantum algorithms such as Dwight-Johnson or Grover's search and source factorization leverage these properties, and it is not like quantum computation is not deterministic like classical computing. It is probabilistic, which means that the end result cannot be known ahead of time. Instead, only the probability distribution of possible outcomes can be known. To better understand this, picture a qubit as a weighted coin floating in the air, something like not knowing if a flying coin is head or tail. Is kind of like this. Quantum gate operations can be thought of as steps that change the way the odds of these events are distributed. When you measure the qubit, it breaks down into heads or tails, which is like getting the coin. Importantly, this is not a random process. In a quantum process, the qubit genuinely holds both values simultaneously. It explores all possible paths, unlike classical process where measurement at the start or end yields equivalent result, as you can see the image on the screen. So our primary objective is to provide a comprehensive understanding of quantum computing, focusing on its application within the NISQ era. The problem at hand is the complex terrain of the NISQ era in quantum computing, characterized by noisy qubits and the absence of robust error correction. While this era holds great promise for quantum technology, it simultaneously presents formidable challenges, including limitations in scalability and reliability. Our goal is to navigate this terrain and unlock the potential of NISQ quantum computing, bridging the gap between its present state and future applications. We must find the ways to harness its capabilities while addressing the ethical and societal considerations that come with it. And this work will help us embark on a quantum odyssey seeking to advance quantum computing while acknowledging and mitigating the limitations and ethical dimensions associated with it. To truly comprehend this research, we must start at the foundation of quantum computing. Quantum computing leverages qubits, the fundamental units of quantum information. As we already discussed in the intro, unlike classical bits, qubits can exist in multiple states simultaneously, a property known as superposition. Quantum gates manipulate these qubits, providing the computational power that quantum computing is famous for. However, in the NISQ era, we face a unique set of challenges. The challenges include the noise inherent in quantum system, which can disrupt quantum computation. Moreover, NISQ devices are categorized by their limited qubit counts, restricting focus on addressing these limitations and finding a delicate balance between exploiting the incredible potentials of quantum computing and dealing with the practical challenges imposed by noise and qubit restrictions. One of the central aspects of this research lies in quantum algorithms, the true engines driving quantum computing's transformative potential. Gruber's quantum search algorithm is a fascinating algorithm that have been explored extensively. It is a powerful tool for searching specific items in unsorted databases. What's remarkable is that it outperforms classical search algorithms by providing a quadratic speedup. Source quantum factorization algorithm is another cornerstone of this research, and it has the potential to revolutionize cryptography. Source algorithm can efficiently factor large numbers, which poses a significant threat to classical encryption methods. Variational quantum eigensolver is another key algorithm have been explored for quantum chemistry simulation. This algorithm empowers us to explore molecular structures and properties with unprecedented precision, which is invaluable for drug discovery and material science. Additionally, we extend into the world of hybrid quantum classical approaches. These approaches fuse the strengths of both classical and quantum computing, enabling real-world problem solving. Furthermore, the noise-tolerant quantum approximate optimization algorithm has been a focus, enabling optimization takes even in the presence of noise, which is a common challenge in quantum computing. In the realm of quantum computing, programming paradigms plays an instrumental role in realizing the potential of NISQ quantum computers. This research has navigated the evolving programming landscape. This landscape includes a variety of tools and resources designed to simplify the development of quantum applications. A central component of this landscape is quantum programming language. Examples include Qiskit and SARC, which provide the foundation for writing quantum code. These languages bridge the gap between quantum hardware and quantum software, making it easier for researchers and developers to harness the power of quantum computing. Development frameworks have been instrumental in streamlining the creation of quantum application. These frameworks offer a comprehensive set of tools and resources to simplify the development process. This work has also extensively explored hybrid quantum classical programming, a paradigm that seamlessly integrates classical and quantum computing resources to tackle complex problems. By optimizing the synergy between classical and quantum components, we can address real-world problems effectively. Additionally, we have leveraged quantum algorithm design tools, which assist researchers in creating efficient and practical quantum algorithms for a variety of applications. As we delve further, it's vital to address one of the central challenges of NISQ quantum computing, noise. The NISQ era is characterized by noise, which can disrupt the quantum computation. Preserving quantum information and ensuring reliability of quantum calculations in this noisy environment are essential objectives. Quantum error correction codes are fundamental to this effort. These codes are designed to detect and correct errors that can occur during quantum computations. The research explores the principles and implementation of these codes with the ultimate goal of achieving fault-tolerant quantum computing. This is a long-term aspiration that involves creating quantum systems that are highly resilient to errors. In the interim, we also focus on quantum error mitigation strategies. These strategies aim to reduce errors and improve the quality of quantum computation. They include techniques like error. They include techniques like error extrapolation and error mitigation through classical simulations. Furthermore, we have delved into the concept of error correcting quantum gates. These gates are designed to enhance the fidelity of quantum operations, providing a means to improve the overall reliability of quantum computation. In the practical realm of NISQ quantum computing, this research has revolved around the realization of quantum hardware. This encompasses the architecture and physical implementation of quantum devices. It's here that the magic happens, where qubits come to life. Quantum hardware realization is a complex but essential part of the quantum ecosystem, and this work has delved into the intricacies of this process. We also extend to the realm of annealing-based quantum platforms with the focus on platforms like those offered by D-Wave systems. These platforms offer unique problem-solving approaches and are particularly suited for specific problem sets.
Dr. Swati, sorry to interrupt. Please conclude your session now, please.
Okay, sir. So for the applications, one of the key applications where NISQ computing makes a substantial impact is cryptography and security, optimization problems and machine learning, quantum machine learning, quantum chemistry and material sciences, and real-world applications like supply chain and logistics. So we envision a future that extends beyond the NISQ era. This future involves like transiting to fault-tolerant quantum computing, and the systems becomes highly resilient to errors. Achieving fault tolerance is a challenging yet critical long-term goal, and this work is dedicated to exploring these strategies that will take us there. Like advancement in quantum error correction, we also discuss the concept of quantum supremacy and the milestone beyond it. Hybrid quantum classification computing, a paradigm where quantum advantages are coupled with classical computing resources. It plays a pivotal role. And additionally, we emphasize the importance of scalability in quantum computing and the innovations in quantum hardware that are driving the field forward. For ethical and societal consideration, data privacy and cryptographic vulnerabilities are pressing concern in the context of quantum computing. It also extends to the equitable access and mitigation of these technologies. Like access to quantum technology must be accessible to all, and we explore strategies to ensure equitable access. To conclude, as the culmination of this twist approaches, we engage in introspection regarding the obstacles and limitless possibilities presented by the noisy intermediate scale quantum. The future holds great potential for transformative advancements in our world through the utilization of quantum computing. The potential of the quantum future is huge and holds great promise. Without current understanding, only scratching the surface of what it may offer. The promotion of ongoing investigation, scholarly inquiry, and cooperative endeavors is advocated as we embark on our discovery of the quantum domain. These are the few references of our paper. Thank you.
Thank you, Dr. Swati, for your presentation on use of the quantum Odyssey. I would request Dr. Ibrahim and Dr. Rubina for the questions.
Okay, let me start. I'm not an expert in quantum computing, so my only question is, it looks like more like a general information about the quantum computing. And is there anything that is your contribution which is related to the AI and quantum computing?
Sir, can you repeat? There's some network issue. Your voice is not audible here.
Okay, as this session is everything is related to AI frontiers. Is there anything related to AI in this work?
Sorry, sir, your voice is not audible.
Is it not audible for everyone?
Yes, you are audible, Dr. Ibrahim. You are audible.
Okay, so I'm saying you seem to explore the quantum computing in all fields. Have you particularly kind of explored quantum computing just for AI in this work? AI means like artificial intelligence.
Sorry, sir, I'm not getting the question.
Okay, yeah, thank you.
Thank you, Ms. Swati, for introducing us to this NISQ era in the quantum. And I agree with Dr. Ibrahim that it's just like a overall tour for what is quantum and what is this NISQ era. Just one quick question for you. You didn't present any proposed architecture or something, proposed model or any algorithm which works on this?
This paper's purpose is to inform the audience about the state and potential of NISQ quantum computing. We just deeper understanding of this technology and its implications.
It's just proposed. I mean, it's just a theoretical in theory. Is it applied anywhere?
It's theoretical. It's like a comprehensive exploration of this NISQ quantum computing to give a better understanding.
Okay. Thank you, Ms. Swati.
Okay, thank you, ma'am.
Thank you, Dr. Swati, Dr. Ibrahim, and Dr. Rubina. I would like to call the next paper ID 432, paper ID 432, and the title is Optimizing Security Measures in Decentralized Mobile Networks with Neurosophic Fuzzy Topology and PKI. Yes, I think the authors are available. I request all the authors to finish your presentation in 8 minutes. Then we will start the question and answer. I think Dr. Mahmood is available. Please share your screen. Yes, and start. Please start.
Thank you very much for giving me the opportunity to present my work. So I am very happy to participate in third International Conference on Technological Advancement in Computational Science. I will start discussing about optimizing security measures in decentralized mobile network with neurosophic fuzzy topology and PKI. Our authors, we are 5 authors, Professor Dr. Rohit Banhantagar and Professor Dr. Mahmoud Shams, Dr. Ahmed Mabrouk, Dr. Zahra Tariq, and Dr. Ahmed Sanam. At the first, the content of this paper includes abstract introduction, existing system, lecture survey, proposed architecture, results and discussion, in future enhancements, references. In the abstract, we will discuss about one of the major and one of the most important topics about uncertainty variables is enhancing security in decentralized mobile network using neurosophic. Neurosophic is an uncertainty variables that utilized local function algorithm to optimize the local function D stars, P stars, and A star for optimization. This optimization based on decision variables C, B, and A that enhance the security measures. Also, the security measures includes 3 important categories: confidence, integrity, and specificity. The results we reach to optimal values of C, B, and A by determination of various conditions. This value is increased with the number of nodes that is described in mobile ad hoc networks. The proposed method significantly improves the security of decentralized mobile networks and adaptable to large networks as T, L, and V values increase with the node count. The study proves the effectiveness of the proposed method in enhancing the security of decentralized mobile network. What about neurosophic sets? Neurosophic sets provide a mathematical framework for addressing neurosophic phenomena in a real world, utilizing membership, interdeterminacy, indeterminacy, and non-membership on a generalized unit interval. Ad hoc network. We also know that MANET network is temporary wireless network for a specific purpose without central infrastructure. And it will be helpful for any places like places wires and have no infrastructure. Therefore, the advantages and the limitation in comparison to traditional wireless networks, ad hoc is used to make an objectives to eliminate base station in scenarios requiring quiet communication and rescue operation. Here is the security challenges. Security in MANET, mobile ad hoc network, due to their dynamic and resource constrained nature, various security mechanisms proposed, but the challenges to implement. Therefore, the application of MANET is to find us in military application, commercial, and unique applications such as informal confidence, robot-based networks, smart homes, and disaster recovery. We have also self-organizing network that manage are self-organizing transient network with wireless nodes serving as both routers and terminals. Routing protocol, multiple routing protocol designed to address managed advantages and drawbacks. Here we have the enhancing managed security with neurosophic fuzzy logic approach and BKI, public key, and highlights the importance of security in mobile ad hoc network. We have also neurosophic fuzzy topology by explaining the concept of neurosophic fuzzy topology and discuss how it combines with fuzzy sets and neurosophic logic for modeling topology. We also have the managed characteristic by presenting key characteristics of managed, such as the limited infrastructure, bandwidth restriction, power consideration, and security challenges. And we have emphasized the need for robust security solutions. Firstly, the public key security, PKI. We have explained the PKI as a security mechanism using asymmetric cryptography by highlighting its advantages, including the message integrity, confidentiality, and authority. There we have the characteristics of managed topology. In security application like confidentiality, integrity, availability, authorization, dependability, accountability, and non-repudiation. The challenges in PKI, public key security, is overhead and decay management, and the need to address these challenges for effective security using neurosophic approach. Neurosophic fuzzy topology introduced the proposed neurosophic fuzzy topology model to enhance managed security and emphasize the combination of neurosophic fuzzy local function NFLF and public key. Therefore, a neurosophic fuzzy model with a k size determination we have in the speakers 25, 50, 75, 100, 120, and the 25 ATC. This is explain how the models determine k size. This is a k size based on password length, frequency of which it changes, and the number of neighbor hosts by highlighting the role of password length and regular change in enhancing security. This is determine the neurosophic set membership function, non-membership function, and indeterminacy. This is what differ from fuzzy and neurosophic is there are three important parameters: membership function, non-membership function, and indeterminacy. Therefore, the security assessment is discussing the comprehensive assessment of security and suggested model explain the computation of neurosophic local function and its role in security communication channels. Therefore, the output and decay distribution explain the output of the model, including the number of bits and security level. Describe the key distribution procedure in managed using PK public key scheme. Here is the key determination in opposite to the neurosophic at the security level. Security level analysis, or ASL, analysis of security level, evaluation for membership function, non-membership function, and indeterminacy, which are the most three important parts in neurosophic analysis. We have scales from 0 to 5 membership function classification between 0.015 and 0.026. Non-membership function classification between 0.004 and 0.038, and indeterminacy between 0.937 and 0.981. This will appear in the security level for mobile nodes from 25 to 250 nodes. The correlation states a strong negative correlation between percentage from the average classification and indeterminacy, which reaches to 92.3%, and reaches to very strong negative correlation between percentage, average, and non-classification, and indeterminacy reaches to 0.966, which are very promising percentage. Secondly, the K generation time, we have measured the K creation time from 0 to 1. And we have indeterminacy classifier, which are very quick, which reach to 0.06 to 0.15 membership function with a non-membership classifier with a slower K creation time, which is minimum creation time. Therefore, the non-membership function in indeterminacy and the KCR of membership function with a neurosophic classifier. We have also the BKI and the BKI characteristics with the public K infrastructure and non-public K infrastructure in the context of the framework with 250 nodes. We have seen that the accuracy reaches to more than 90%. So the fuzzy neurosophic security with a PKI, the finding indicates that the PKI offers significant stronger security to traditional non-PKI methods, which represented by scale 0 less secure and 1 most secure. When we have 2, 1, we indicate that the security is in high level. For non-PKI security, this changes from 0.15 to 0.45, which indicates that it may be decreased and the security level is negatively. So we suggest to use BKI and neurosophic approach for fuzzy neurosophic security for MANET. And we have also the results show that BKI provide faster processing time, which reaches to 0.3 seconds, which indicates that our methods with encryption is decreased and reached to 0.3 seconds. Here is the neurosophic fuzzy topology and BKI with different nodes and with different values of 3 neurosophic fuzzy dataset A, B, and C, and we enhance the A, B, C, and C to the optimized value, which indicates that the anomaly score levels and the KCR indicates that our proposed models achieves high security levels with a minimum time. Here, this table indicates the number of nodes that varies from 25 to 250 nodes. This is the ACL and the KCR, which indicates that our proposed methods have obtained security level, high security level with high security. Finally, the conclusion and future work, neurosophic fuzzy topology offers valuable methods for augmentation with MANET. The benefit of this strategy include improved routing, clustering, load balancing, message authority, and even it may result some communication and computational cost. There are still a number of issues that need to be resolved, such creating a more effective version of these methods by creating system with a safe key management. To create more complete security framework for MANET, we have future directions that we will work on PKI with neurosophic fuzzy topology, and we have also measured some other approaches using fuzzy logic, using with MANET, we're using neurosophic fuzzy topology and PKI. And it will be more efficient to use also some models like EES and rough sets. Thank you for presentation.
Thank you, Mr. Mahmood, on the presentation based on the optimizing security measures. I would like to request Dr. Ibrahim and Dr. Rubina for the questions.
Thank you.
Thank you, Mr. Mahmood. No questions from my end. Thank you so much for your work.
Thank you very much.
Yeah, thank you very much. It was very nice work. My only concern is that it would be very nice if you kind of highlight your own contribution and the other more clearly, because I couldn't get where was your contribution. It seems like the whole paper was your contribution.
Yes,
if it's so, like, yeah.
Yes. You asked about the major contribution of this paper, okay?
Yeah.
The major contribution Ibrahim is focused on using a neutrophobic fuzzy approach. Neutrophobic is one of the uncertainty measurements like probabilistics, like fuzzy logic approach, like neurofuzzy. This is modern approach. Uses three important categories that are membership, non-membership, and indeterminacy. These are collected to measure the different scenarios of the holes or the black holes of MANET. You know that MANET, a mobile ad hoc network, is no need to infrastructure. Therefore, we have to check the black holes in the network, and some fuzzy, some probabilistics variations in the network, inside the network, needs to be encoded. So we have in the past using RSA encoding, using AES encoding, but in this case we have used neutrophobic approach as an effective method to enhance the security level of PKI security levels of MANET.
Okay. Thank you very much for your answer.
Thank you, Mr. Mahmood, Dr. Ibrahim and Dr. Rubina. Mr. Mahmood, you can unshare your screen. Thank you.
Thank you very much. Okay.
I would like to call the remaining paper IDs. The paper IDs that are remaining are 351, 460, 42, and 355. Remaining paper IDs, I'll repeat, 351, 460, 42, and 355. If any one of the authors of these paper IDs are present now, please start your presentation. If any author of the paper IDs 351, 460, 42, and 355, is anybody present? If one of the author of these remaining papers are present, please start your presentation. Dr. Ibrahim and Dr. Rubin, I think these paper IDs 351, 460, 42, and 355, their authors are not present in the current meeting, I think, in this session.
Okay.
Okay, Dr. Patil.
Okay. Being a moderator, I want to end the session by proposing the vote of thanks. We sincerely thank the session chairs for their valuable insights on the presented articles.
Yeah.
Yes.
Hi, sir. Am I audible?
Yes, Mr. Gurpreet, right?
Yeah, Mr. Gupta. Yeah, sir.
Your paper ID?
It's 42.
Dr. Ibrahim and Dr. Rubina, paper ID 42. Author is present. We shall allow him, right? Permission?
Yeah.
Yes, sure.
Permit, then they will present. Okay.
Thank you, sir. Thank you so much.
Paper ID is 42 and
Sure.
experiential analysis to measure the impact of data size on accuracy of deep learning model to detect and classify monkeypox using skin lesion images. You may start now. You have 8 minutes for the presentation.
Sure, sir. Thanks a lot.
Yes, please share your screen. Your screen is not visible.
I hope that's visible. Yeah, sir. I'm audible and it's my screen is visible. Thank you so much. So great. So my name is Mr. Vikas, and as well you can see on screen, our paper title is an experiential analysis to measure the impact of data size on accuracy of deep learning model to detect and classify monkeypox using skin lesions and images. Perfectly. And this is been on the TOC page. I'm going to start with abstract, objective, and the proposed methodology, so and so. Perfect. So here, you know that the objective, especially for this research, is to validate or to find out the relationship, especially in between the accuracy and the size of the data. And when we started this journey to find out the research in this relationship, so our initial job was to find a direct linear relationship of the data size with the accuracy. But as we progress into this one, then we had different observations. And finally, we got to the different conclusions of it. But as per we see the data size is increasing on that, the model has a different impact onto that. Accuracy has a different impact on that. And there are different other parameters that actually come into play. And not only the accuracy we should be considering. Okay, so in order to make these observations, so we had 2 data sets that have been taken care of. And initially we start with a small data set, and as per the data increases, then we have checked that what kind of measures and what's the impact on the different performance metrics of this model accuracy and the different parameters like recall value, or is it about the FN score? So what's the impact on that? So it's have been a complete journey of the measurements. Great. So these are some of the impacts or the outcomes that have been shared with of different papers with it, and also we're sharing that what we have done in this one, and that's the literature survey. So there are certain papers where the mobile V2 and different algorithms have been implemented with mobile V2, V3, and so and so, and with their accuracy and all. Good. So this is the proposed methodology that we have done. So we had been done initially with the 2 data sets. The first data set we started with initially for 20 images, and the second data was collected that was more of 2145 images as the input. And into the pre-processing stage, when we process the images and it has been resized, so the resizing of the image was about, it was into 224 into 224 of the pixel size, and then it was normalized. Then data encodings have been used. That was the 1-port encoding that was used, and then finally it was augmentation. In augmentation, that all the images have been combined together at a single source. And in the image pre-processing stage, we have converted all these images into a fixed size, and then an array conversion is there, so that in order that the dimensions of the images, they can be neutralized, they can be flattened, and we can create rather a complex model, we can create a simple model, and that can be trained perfectly, and so that we get the perfect outcomes. And for the processing also, we have used in this one the OpenCV for the Python, so that we can scale it. We can have the procedures to standardize the dimensions, and we have reduced the size of all these images to a fixed size of 224 into 224 pixel size. And after that, then images have been normalized. And so that all the differences, something like if the images have a noise, it has the lighting, the contrast, they all can be easily normalized, and they can be at a single of the same kind. And further, what we did change into, we have been all the image pixels value that were from 0 to 255 scale, we have reduced to, we have transformed to 0 to 1 range. And finally, the last job was to transform all these images or with the concept of label encoding. So we use one-hot label encoding in this course. Since this is a concept based on multiple classifier, that's the reason we have used one-hot encoding in this case. Now, this is the algo we have used at the backend. It's based on purely on CNN concept, that is convolutional neural network. And the algo here is mobile V2. And the architecture, it's been already mentioned in the papers, so we all know about it. And we know that it's a combination of depth-wise separable convolution layers, where we create a bottleneck of layers. And then mobile net, it actually reduces the number of parameters and what combination, what calculations we are implementing. Okay, it's all been done by mobile net V2 at this stage. And okay, so this has been a great compatibility. It's very much suitable for the mobile devices. That's the reason we have used this algo for it. And this is the final outcome of this one as a confusion matrix. These are, you can see the confusion matrix is there, and most of it has been giving a great accuracy of it. We have the true positive as a 1159, and false negative is given as 971. So it's giving us a very good outcome if we check it out. Now this has been okay. The first model that was with the 420 images. So we can check here. There is a comparison of the epochs with the accuracy, and we can see that as the number of epochs are increasing, accuracy is also increasing to it with the comparison of training and testing sites. Now there is a complete separate comparison of 2125 images. That's the second model that we tried with. But as we see that as the number of epochs are increasing, again, the accuracy is there, but there is a huge variation in these outcomes of both these two models. Good. And here is the final performance evaluation or the outcome of you implementing this mobile V2 algo. And we see that there are actually, now this time there are three models. Into this one, the first is with the 420 images, where the model accuracy comes around to be 0.97, but with 1764, it's around 91, moreover 91%. And finally, we have image size or data size is around 2145 images, and 96% is around is the accuracy. So as I told earlier, it was not a journey only of finding the accuracy or focus not only on the accuracy, but we have also evaluated the different parameters. So when we increase the size of the data sets, linearly we can check that there is a huge variation in the validation accuracy. FN score is increasing every time, precision also increasing every time, and recall value also increasing at this time. Okay, so we can figure it out. Like this is the way out, that it's not only the accuracy that actually hampers when the data size is increased, but these performance metrics are also one of the greatest factors that should be considered. Now, further job into this one will be to mold these complete data sets so that we can have something more into the research part of this one, and then we'll be sending these kind of research into some journal paper. Perfect. And finally, the conclusion when it comes into this one, so it shows there is no direct relationship of the data size with the accuracy. It's not always that when increasing the data size, which surely will increase the accuracy of the model. It's nothing like that. But the measurements of the different performance metrics like FN score, precision, recalls, they're also some of the performance metrics for the evaluation should be considered, and they usually increase with the size of the data sets. That's the outcome. We have got it. And further, we are sure about it that we're going to have some sort of experiments so that we can make it more clear about the relationship of data size and accuracy in the time to come. And these are some of our references that have been used here. Thank you so much. And hope I finish on time.
Yes, exactly.
Yeah, thank you so much.
Thank you, Mr. Vikas, on your presentation on use of deep learning model.
Yeah.
I would like to request Dr. Ibrahim and Dr. Rubina for the questions.
Okay, thank you, Mr. Vikas. It was a nice paper. My only question, like when you choose the different size of data set, did you select those number of images from the same data set or different data sets?
Actually, they are from different data sets. They are not from the same data set. We have used different data sets.
So then then I have a concern about this kind of experiment because different data sets could have a different kind of information because the bigger data set could be some kind of, there might some redundant information, could be unbiased. Those kind of factors are very important, I think. And even though when you select from the same data set, you have to keep the data set balanced kind of in order to be a fair comparison. Yeah, that was my question.
Yeah, perfectly okay. I'm agree with that. But what we have done into this one, there are 3 different data sets, but on the and the concern is the same in all the cases. The images, they belong to the different boxes, right? So that have been compared with the same algorithm. And surely I will consider this point, but when we'll implementing the further research into this one, so surely that will be taken care of.
Yeah, thank you.
Yeah, thank you so much.
Thank you, Mr. Vikas. My question is already covered by Dr. Ibrahim.
Okay, great. Thank you so much.
Thank you.
Thank you, Mr. Vikas. You can unshare your screen now.
Okay.
Next paper IDs that are remaining are 351, 460, and 355. Any author of this paper ID 351, 460, and 355. If anyone of the author is present, please let us know and you may start your presentation. Paper IDs 351, 460, 355. Dr. Ibrahim and Dr. Rubin, I think these authors of these 3 papers are not available. We'll start the concluding session now.
Sure.
Yes. I sincerely thank the session chair for their valuable insights on the presented articles. Your valuable technical comments and remarks would definitely support the researcher to flourish in their research career. We are grateful to Dr. Ibrahim Atad Jano and Dr. Rubina Khan for your sincere evaluation. Thank you, sir, and thank you, ma'am. I would like to extend our sincere thanks to the presenters, authors, for their significant contribution in presenting their technical observations. Your participation is the key behind the success of this conference. Thank you to each and every presenter for being with us. The best 3 papers will be announced today, that is 3rd November, in the valedictory session from 1:45 p.m. to 3 p.m. Tashkent time. So kindly request you to stay connected with us. Once again, we thank you everyone for your active participation and contribution. Now the session is over. Thank you all.